welcome you to Noble UK Academy. This is an academy for global academic scholars, so you're highly welcome. Stay tuned. Meanwhile, before you go on and on to enjoy this channel, I want you to hit the subscription button. Okay, kindly subscribe to the channel, like my videos, comment if you find it valuable. Of course, it is a channel of value, so you are here to get a whole lot of academic value. Stay tuned. You can equally do well to share my link, my channel link, to other students out there. Thank you. Now today we want to see how we can resolve questions like this, provided you are given something like this in an examination and you are asked to expand. This is binomial expansion. So in expanding, you can actually use combination method. You equally can use Pascal triangle. Pascal triangle is more easier to use because of time constraint in an examination. So I've been able to write out the expansion coefficient. We call it coefficient of expansion. That is to say, for positive integers, you can see these are integers which are positive. Then when n is equal to 0, that is the power is equal to 0, what you have as your coefficient will be 1. That is when you are using Pascal triangle. When n is 1, what you're going to have as your coefficient is coefficient 1 and 1. Okay? When n is 2, that is to say when your power is 2, what you're going to have as your coefficient is actually 1, 2, 1. That is to say, this is how it is being derived. For the first one, you have 1. The second one, you have 1, 1. Whatever you are starting with, you must end with. So for the second one, you're going to have 1, which is your starting point. 1 plus 1 gives you 2. So whatever you start with, you end with it, which is 1. We started with 1, we end with 1. So coming to the third one, we have 1. We begin with 1, we end with 1. So this is 1. 1 plus 2 gives you 3. 2 plus 1 gives you 3. And then finally 1. Coming to 4, we have 1. We're starting with 1. Then 1 plus 3, 4. 3 plus 3 is 6. 3 plus 1, 4. And then you end with 1. If you have 5, power 5, you're going to have coefficients such as 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And then you end with 1, and so on and so forth. So here we are having power 4, meaning that our n is 4. So when you're having this kind of scenario, for you to expand this is as simple as this. Look at what we have here as our power n, when n is equal to 4. Our power 4 when n is equal to 4. So the coefficient is 4. 1, 4, 6, 4, 1. The first coefficient is 1. So if I'm to expand this, I'm going to have x plus y all raised to power 4 will give me, my first coefficient is 1, that is 1 times, in engineering we use dot to represent multiplication, that is times. So the first one I'm having here, the first letter is x, so it's going to be x raised to power 4. The next letter I'm having is what? Y raised to power 0. Of course, 4 plus 0 is still 4, so the power must be 4. Then the next coefficient on the line is 4. So I'm going to have plus 4 dot x raised to power, the first one was x raised to power 4, so it will be reducing by minus 1, while y will be increasing by 1. So if you minus 1 from 4, you're going to have 3. Then our y, add 1 to 0, we're going to have 1. Of course, the idea is that the power will always be the same power. 3 plus 1 gives you 4. So that is just that. The next one, the coefficient is 6. I'm going to have 6 dot x. If I remove 1 from 3, which is 2, then y, 1 plus 1 is 2. The power must always be complete. That is to say 2 plus 2 is giving us 4. Then the next one is going to be, according to our expansion method, it's going to be what? 4, which is 4 dot And then finally, the next coefficient is 1, which is plus 1 dot x. This is x raised to power 1 minus 1 from 1 is what? 0. Then y, this is y3 plus 1. 3 plus 1, 4. So if you add up, you find out that it's still power 4. 0 plus 4 is still 4. 2 plus 2 is still 4. 1 plus 3 is still 4. And so on and so forth. So once you've done this, you are good to go. Now, we have 1 times x raised to power 4, which is still x raised to power 4. Then times y raised to power 0. According to the law of indices, anything raised to power 0 gives you 1. So this is 1 times x raised to power 4 times 1, which will give us x raised to power 4. Then coming here, you can, if you want, you can put all of this into brackets, 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 and brackets, so that the plus will not confuse you. We are done with this, so we'll move to this. This is 4 times x raised to power 3, which is 4x raised to power 3. Then times y raised to power 1, which is 4x raised to power 3. 4x raised to power 3, and then y raised to power 1. In mathematics, we don't use to put power 1. It is as good as y is the same thing as y raised to power 1. Okay? So we move to the next one. We have plus 6 times this gives me 6x squared y squared. Okay? That is for this. Then we move to the next one. 4 times x times y cubed. That is 4x y cubed. And finally, we have 1 times x raised to power 0. According to law of indices, anything raised to power 0 gives us 1. That is 1 times 1 times y4. That is y4. That is y raised to power 4. Okay? So this is what you're gonna have as the final answer. So I hope you enjoyed this simple simplification on binomial expansion. Please ensure you subscribe to my channel, share the link, like the videos, comment on the videos, and then tell a friend about this channel. Thank you.